Hello, today I'm going to show you a demo of Data Workspaces in action. This is a two-part demo. In this, the first part, we'll look at some basic functions of Data Workspaces to support tracking of projects and experiments. In part two, we'll look at how Data Workspaces supports collaboration. To start, I have already created a Python environment with scikit-learn, Jupyter, Matplotlib, and Data Workspaces itself pre-installed. You can find out more details about how to do this in the documentation. We are going to set up a data workspace and then run a few machine learning experiments using scikit-learn and the famous digits dataset. To start, let's go to the command line. We're going to create a directory for our workspace, call it demo. I'm going to go into this directory. Now, Data Workspaces is mostly command line driven, and it has a command interface that's very similar to that of Git, where there's a primary command, DWS, and then a number of subcommands. And you can type help to get the list of subcommands, and you can also do like give this particular subcommand and get help on that. So the command we're going to run first is called the init subcommand. And so this will set up our directory as a workspace. And we're going to also pass in this option to say, I want to, as a part of the workspace, I want to include two pre-made resources, one called code and one called results. So these will be directories within the workspace. So when I run the init command, it's going to ask me a question, which is, what do I want to use as the host name? Because it's going to use the host name in various places in reporting and in directory names. So by default, it's the actual physical host name of the machine, but I may want to change it, so I'm going to just call it laptop. Okay, so it's done that. So if we do an ls, we see we have three directories: code, results, and scratch. So code and results are the repos that the resources we talked about, and you can look in. Each one has a README file that's mainly to, if we look at it, we can do a cat of it. That is basically just a placeholder because Git doesn't handle empty directories very well. And Scratch is just an empty Scratch space, and it's just local to that machine. Okay, if we look for hidden files, we'll see there's actually a couple of hidden files in directories. The .git and .gitignore are created because we're actually creating a Git repository in this directory, and Data Workspaces is acting as a layer on top of Git. So it's going to manage the details of Git for us, but underneath the covers, we're calling Git operations for a lot of the Data Workspaces commands. There's also a hidden directory called .data workspaces that has all the metadata for Data Workspaces. Now, so far we have two resources, but let's add another one. And these two that we have so far are part of the workspace's repository itself. So those are directories within the workspace. But let's say we have a completely independent Git repository that someone else owns and we don't control. It contains our source data. So let's include that as a part of our workspace. To start with, we're going to clone it in. So we'll call the clone command. And then so now we have that Git directory or the Git repository there as a subdirectory. And then what we're going to do is we're going to tell the workspace about it. And we're going to use the add command for that. And we're going to say that this is for source data and it's read-only because this is something we don't control and we don't want to write. And this is a Git resource. There's different kinds of resources. And by default, we're going to just give it a name and it'll be the name of the directory. Okay? And so what this means is that other repository is not a part of our workspace's Git repository, but can manage completely independently. But whenever I want to make copies on remote machines and set up my environment, it'll automatically grab that repository as well. So we can kind of see what we have so far by running the report command, which has many reports, and in particular, we're interested in the status report. And so this shows us a little bit about the workspace. So as you can see, we have three resources: the digits dataset, source data, code, and results. And they have different roles that they have. There's basically four kinds of roles: source data, code, results, and intermediate data. For this project, we won't need any intermediate data. Okay, and we can look and see that two of them are subdirectories and one is a standalone Git repository. Okay, so now let's do some machine learning. So we're going to go into the code work subdirectory, which is also resource, and I'm going to copy over a Jupyter notebook into that, and then we can go to Jupyter and take a look at that notebook. We go to code. So this is the notebook we're going to run. And as you can see, it's fairly simple, and we're importing code from scikit-learn and also from Data Workspaces. And the general idea is that what we're trying to do is with the Data Workspaces is have an integration with the popular machine learning frameworks and make it easy so that you can use the framework pretty much as is, but we'll be capturing additional information that will be stored in the workspace. So in this case, the first thing we're going to do is we're going to load the data files in. And you can load them in directly by calling numpy commands because these are just numpy files. But in this case, what we're going to do is we're going to use this load data set from resource, and it's smart enough, you just give it the resource name. It'll figure out from the metadata where that resource is located and pull the data in for you. And it creates a bunch, which is kind of a hash table-like structure, which is pretty standard for scikit-learn, and the actual data are numpy arrays in that hash table. So the next thing we're going to do is create the model that we're going to train, and that's going to be a support vector classifier, and so this is the call to do that. We're going to pass one parameter gamma, and we're wrapping this call in this thing called a lineage predictor, which is from Data Workspaces. And what this is doing is it's providing the same interface as their underlying model, but it's intercepting all the calls and capturing information. So it's going to capture first what are the parameters we gave it when we created the model. It's also going to capture when we give it input data, where that data came from, and then it's going to finally capture the results and save those to a file. So we'll see that in a minute. So the next step is we're going to do a train test split. This is fairly standard for scikit-learn, and finally then we can train our classifier and then run it on the test data. So let's run this and see what happens. So we'll run all the cells. Okay, it's done. And you can see we got about 70% accuracy. So pretty good. And you also notice this comment wrote results to results.json. So this is the results resource and the file results.json underneath it. So we'll kind of take a look at that next. So let's save this first. Then we go back to the file system. So if we look at results, so there's the README file and there's two new files. So the first one is digits.joblib, and that's a saved image of the model as it was trained. So we can use that to reinstantiate the trained model and run additional classifications. And that's optional, so if you don't need to save it, you don't have to. There's also this results.json file. If we look at this, we can see it's a bunch of JSON, right? So, but that may be kind of hard, but it's pretty easy. You can kind of create this manually with any tool. But we're creating it through the scikit-learn integration. But we can do a report for results, and that'll give us a nice clean view of it. So what we can see is first there's some general information. It's saying that we ran this step digits SVC, which is our Jupyter notebook. It ran at this time, and this was the execution time. So it ran in like 0.3 of a second. Then there's a bunch of parameters. These are all the parameters we passed to the model. Most of them are defaults except for the gamma, which we passed into 0.01. Then finally, there's the result metrics. So these are specific to the particular kind of operation. Are you doing classification or regression? And in case of classification, are you doing a binary or multi-class? In this case, it's multi-class. So we get the accuracy, and then we get some details on each of the individual classes, in which there's 10, one for each handwritten digit, and then some high-level summary data. So this is now saved on the file system, and all this information was automatically captured for us. Okay, so next what we would like to do is kind of save this experiment for future use. So we'd like to be able to save all the metrics and parameters and everything, as well as the state of the workspace that created this. That way, if we want to go back and rerun this, we can get the workspace, all those different resources into the exact same state. So to do this, we're going to use the snapshot command. And so it's basically a subcommand. It takes a message, which is optional, and it takes an optional tag, right, which is a short name. If you don't give it a tag, every snapshot also has a hash associated with it. So it's taken the snapshot and it's been tagged with this tag, and this is the full hash, which is created from the contents of the snapshot, and you can refer to it with the first 7 digits of this hash if you want. But most times it's most convenient to use that tag. So we look at what this did. This made some changes actually to our results. So now we see that those files that we had before are gone, and there's this new directory called Snapshots. So we look in Snapshots, there's another directory. If you look at the name, this is the host name that we told when we created the workspace for this particular machine. So this is basically the machine name and the tag name. So that's kind of identifying that snapshot. And if we look in that, we can find there's all the files that we had, the digits.joblib file and the results.json. And there's this new file, lineage.json, and that contains the lineage data of how we created that result. And there's a reporting thing, DWS report lineage, as we'll see in a minute, that can pre-print that for us. And so the reason that this stuff got moved to a separate directory is that results are typically additive, and you don't want to overwrite your old results with new results. So every time you do a snapshot, it moves them off to a safe place. And DWS knows where that place is so that it can do fancy things with it in terms of reporting. Okay, so now let's go back to our notebook and run some more experiments. Okay, so what I'd like to do is add another 0 to the gamma and see if we do any better. We'll go back up here. We're going to run all the cells. So it's running, and we did much better. Now we got almost 97% accuracy. That's pretty good. So let's save that notebook and then go back to the command line. And what we're going to do is we're going to create another snapshot of this experiment. So that's going to capture the state of the code, the state of the source data, and the state of our results, right? And then there's another report we can run, which is DWS report history. And so that'll show us the history of all the snapshots taken in this workspace. So we see the first snapshot here, it has this tag, and it shows us kind of the first 2 metrics. In this case, accuracy, so you see it was like 70% the first time, and we're much better now with almost 97%, right? And there's the messages we created. So that gives you a kind of a quick view of all the experiments you ran. Okay, so now let's do it one more time. We're going to run one more experiment. So we go back here, and let's add one more 0 and see if we can do even better. Okay, we add another 0, we save that, we're going to run the notebook. Not as good, so we got basically about 94%. But even though it wasn't as good, we still want to save this because that kind of keeps track of what we've done, and we can know, oh, did we run it with this option of value for gamma, and how did it do? So we'll create a snapshot anyway. Okay, so we've taken a snapshot. And so now if you look at the results and snapshots, you can see now we have 3 snapshot directories there. Okay. Now the thing is, the best result was actually the second snapshot. So we might want to restore that state so that if someone else is running experiments, they could start with the best thing we had. And so there's a DWS restore command, which will put the workspace into any prior state where we took a snapshot. And you can also do this, you can kind of say, I only want to put these resources in the prior state and not leave others. So there's all kinds of mixing and matching you can do. But we want to go to this second snapshot. So let's run that. Okay. So it's going to ask me, do I want to do this? And we're going to say yes. And notice that the results one will be left alone because this is an additive one. Okay, so we restored to that, and so let's go and actually close this notebook and then reload it, and we should see that we have this is now back to the case where we had 96% and the 0.001 instead of 0.0001. gamma. So this is kind of the best status we had. Okay, so that's it for part 1 of this demo. In part 2, we'll continue and see how we can publish our workspace on GitHub and then collaborate with others. Thanks a lot and see you soon.